So we looked at permutations. What's a permutation? We said it was an ordered arrangement. Oh, he's back. Talk to me. Come on in. We said it was an ordered arrangement when the order matters. We said we brought in the notion of NPR. That was taking n objects r at a time. What we want to talk about, permutations with restrictions, the nasty questions. The nasty questions. Unfortunately, questions, Grayson, that seem fairly easy can get very, very tricky very, very quickly. So, in many problems we wrote, restrictions are placed on the order in which the objects are arranged. And here's the key idea. I am going to give you a couple of questions with restrictions, and just like before, deal with the restriction first. Even if it's talking about the last object or the last number or the last letter, deal with it first. Okay? Many problems in this lesson can be solved using the fundamental counting principle. This is my fallback. I'm going to draw a blank and a Scrabble bag, and usually I can figure stuff out. There may be shorter ways to get there, but I'm not comfortable enough with all of the shortcuts yet, being very honest. So let's try some. It says, answer the following questions using the fundamental counting principle and factorials. Well, okay. This one, maybe I can do both. In how many ways can all of the letters of the word oranges be arranged if there are no further restrictions? Okay. Can you all underline the word arranged, please? If you see the word arranged, that tells you it's a permutation. That's my trigger word. Like when Darian asked the textbook question, how many ways can they be arranged on the shelf? Okay, this is actually the same as Darian's textbook question. In fact, often what we'll do is we'll turn questions into words. How many letters in this word? 7? Are they all different? Okay. Tomorrow we'll ask, hey, what if some of the letters repeat? But for now, are they all different? They will be today. You know what? One way I could solve this is with the fundamental counting principle. How many letters are there in this word? I could draw 7 blanks. Dominic says, I'm good at drawing a blank. 3, 4, 5. How many choices are there for the first letter? Once I've chosen that letter, how many choices are there for the next letter? What? 6? Then? You know what? Here I would use, what's the shortcut? What's an easier way to write that? Okay, so let's write 7 factorial. Crunch that on your calculator. 5,040? This I'm comfortable using the shortcut, but very rapidly I won't be. B, there's a restriction. What's the restriction? First letter must be an N. Let's draw blanks again. 1, 2, 3, 4, 5, 6, 7. Brendan, what's the restriction? So it has to be an N. How many ways are there to choose an N? How many ways are there to choose an N? 1. Okay, you chose an N. By the way, they could have said, instead of the first, they could have said the third letter must be an N. I would have done the third letter first. I would have just dealt with, or they could have said, well, the fifth letter must be an N. I would have dealt with that first, no matter where it was. The fact that it's the first letter doesn't mean, that's not why I dealt with it first. I dealt with it first because it's a restriction. Is that okay, Julie? So we picked an N. Brendan, how many letters are now left? Then. What's a shorter way to do this? 1 times 6 factorial. Would I bother doing the 1 times? Will that change the answer? Okay. 720. I'm good with that so far. Shortcuts work great there. But again, I want to emphasize, Taylor, my fallback is I'll draw a blank, and if I need to, do the Scrabble bag and physically count if I have to. And by the way, then we're using the fundamental counting principle. The reason we're multiplying, that's the fundamental counting principle, Mackenzie. The fundamental counting principle says if you've got 7 choices and you know how many choices you have for each step, multiply along the way. Example 2. 3 girls, let's call them girl 1, girl 2, girl 3. And 4 boys, let's call them boy 1, boy 2, boy 3, boy 4, are to be arranged in a row. How many ways can this be done if there's no other restrictions, if we don't care? You know what? That's the same as the question we just did. How many objects are there in our Scrabble bag? 7 factorial, which is what? Okay? Okay. The photographer decides that he could take a better photograph if no 2 people of the same gender can sit together. He's going to alternate. How many girls are there? How many boys are there? So what gender does he have to start with? Okay, because there's 1 more boy. So let's draw over here 7 blanks. 1, 2, 3, 4, 5, 6, 7. And we're going to go like this. Boy, skip, boy, skip, boy, skip, boy. Girl, girl, girl. I'm ignoring part I where it says show 1 arrangement. I'm going to try and solve it in one fell swoop. Let's just look at the boys. How many choices do we have for the first boy?
4.
Okay, we picked 1. How many choices do we have for the second boy?
3.
How many choices do we have for the third boy? How many choices do we have for the fourth boy?
1.
How many choices do we have for the first girl?
3.
Then?
2.
Then?
1.
Now, in hindsight, now that I've drawn that, I notice that in red I have, right? And in green I have, but I'll be honest, I didn't spot that right away. I only spotted it after I drew a blank. What is 4 factorial times 3 factorial? 3 factorial is 6. 4 factorial is 120? 144, that's what I said. 144? Apparently, there's 144 different ways that we can rearrange boy, girl, if we have 4 boys and 3 girls. Or, if you have 4 girls and 3 boys, same question. Okay. Example 2 to me is all fair game. I like example 2. I like example 2. In that level of difficulty, I'm okay with that. Probably. Oh, Taylor's taking the role as well. Well played, Ben. Leaving the gap. Example 3.
To be fair, you only said it twice.
True enough. Example 3. 6 actors and 8 actresses are available for a play with 4 male roles and 3 female roles. Can you all look up? Underline the word. Who remembers, what does and mean? Doesn't mean add, not in combinatorics. This is in combinatorics and in probability 5 and 4 is 20, not 9. Everywhere else, what's 5 and 4? 9, but not in combinatorics because of the fundamental counting principle. In other words, I'm saying somewhere there's going to be a times sign. Heck, I'll draw that because I feel better. Okay. How many actors are there grand total? How many actors are there grand total? Don't keep it very obvious. 6. How many of them are we choosing for the first group? How many of the actors are we choosing? Read the question. 4. How many blanks should I draw? 4. How many choices do I have for the first actor? Then? How many actresses are we choosing? How many blanks am I going to draw? How many choices do I have for the first actress? Then? So that'll get you there. Now that I've written that, I say, hey, before I start going to my calculator, I can write this shorter. 6 times 5 times 4 times 3. Really, that is from 6, permutate 4 of them. I can use that function. And, Giancarlo, what does and mean? And from 8, permutate how many actresses? Either of these approaches is fine. I'll be honest, I don't see that red approach right away. My fallback when I come to a weird question is, don't take this wrong, I'm good at drawing a blank. Whether you want to do it the long way or the short way, I don't care. Often I'll write it out the long way, and then I'll spot the shortcut, and I'll do the shortcut on my calculator because it's less typing. What's the answer? Sorry, read me the digits. What?
It was 120,000.
120 960. That'll be easier because we're going to be in the millions or trillions. Like you're going to find, I'll often just say, read me the digits, or you'll hear me say, read me the numbers and how many zeros on the end. Right? Oh, it's a 137 and 8 zeros. Good enough. So far, so good. Okay. Example 3, also to me, totally fair game. Turn the page. Andrew was asked to determine the number of arrangements. You know what? I would probably underline that. That's a trigger word. Psst. You guys with me? Number of arrangements of the letters of the word brains. We're going to use them now, Jake. Brains. We're going to use them. That focus here. In which the vowels are together. Okay. What's the restriction here? What does that mean? My Scrabble bag is going to look strange, and this is where I would fall back to my Scrabble bag analogy. I would say this, there's going to be a B, there's going to be an R, then there's going to be a weird letter that looks like that, but I'll treat it like one letter because it says the vowels have to be together. Then an N, then an S. So although the word brains has 6 letters, how many tiles are there in my Scrabble bag?
5.
See it? 5. How many blanks am I going to draw? 5, not 6. 1, 2, 3, 4, 5. How many choices do I have? 5, 4, 3, 2, 1. That's 5 factorial. And this is wrong. This is the right start, but we've missed something very subtle. But if they say certain letters have to be clumped together, then, Matt, my fallback is I'll do the Scrabble bag and I'll put those certain letters on a Scrabble tile. Here's the problem. I didn't have to write it AI. There's another way I could have written that. Another order, another arrangement. How many letters are there on that little mini Scrabble tile? How many ways are there to mix up 2 objects? By the way, 2 factorial is just 2. This is fair game, but getting tougher because almost everybody is going to go 120. Or they're going to go 6 factorial and tell me the answer is 700 and whatever. It's 5 factorial times 2 factorial, which is what? 240. Do you see why, folks? Do you see why we had to do it that way? So if they give me a restriction, Hannah, where stuff has to be clumped together, my fallback is my Scrabble bag. I'll draw a weird Scrabble tile with everything that's clumped together, And then I'll ask, did they say it had to be in that order? If they, by the way, if they had said it had to be AI, then I wouldn't worry about that 2 factorial. But if they didn't give me any condition, then I ask, how many ways can I mix up that little mini Scrabble tile? Putting it all together. Example 5 says, find the, oh, did I miss this already, Mr. Dueck? Already there. Find the number of permutations of the letters in the word kitchen. Okay, how many letters grand total? 7. I'll keep that in mind. If, the letters KCN must be together in the order KCN. I'm going to use a Scrabbled grab bag. It's going to look like that. And this is good bang for your buck. Those of you that have had me before know if I'm drawing extra work, it's really good bang for your buck because you know I have a tendency to avoid. This clears up most of my misconceptions. I'm going to have this weird funky Scrabble tile. KCN. What else? What other letters are missing?
I. T. H. E.
Okay. Brendan, how many letters are in this grab bag? How many Scrabble tiles are in this grab bag actually? Count carefully. 5. How many blanks am I going to draw for part A? 1. Oh, change colors, Mr. Dueck. 1, 2, 3, 4, 5. It's going to be, can you tell me the shortcut for this part? It's going to be, okay, it's going to be 5 factorial. I'm going to write it out, but I'm already proud. I'm starting to spot some shortcuts, right? It's going to be 5, 4, 3, 2, 1. Now, did they say that I'm allowed to mix up the KCN in part A, or did they say keep that in that order? Which would mean technically I would say I have one more way, but don't bother multiplying by the 1. You can write it if you really want to, but you know what? I only have one way to mix up that tile. It's just going to be plain old. Are you going to type 5 times 4 times 3 times 2 times 2 times 1 on your calculator? No. 5 factorial. 120. B, almost the same question, except what's the change? Okay, so still 1, 2, 3, 4, 5 Scrabble tiles. Still 5, 4, 3, 2, 1. And I'm allowed to mix up the special Scrabble tile. How many letters are on that Scrabble tile? How many ways can I mix up 3 objects as a shortcut? No. How many ways can I mix up 3 objects? This goes back to your book question, Darian, which was the the simplest version of picking a group and mixing it up. It's n factorial. Hey, what is 5 factorial times 3? I can do this in my head. 3 factorial is 6, so it's going to be 120 times 6. Is the answer 720?
Yes.
Okay. Okay. Let's apply this to something you may have wondered. You're going to a hockey game with some friends. Hey, how many ways can you sit? So, how many friends are going to this particular hockey game?
6.
Okay, so they have 6 tickets. How many different ways can they rearrange who they... So A just asks, how many different ways can they sit together in seats A3 to A8? By the way, A what? 3. A what? 8. What is 8 take away 3? Why is that 6 seats? Okay, you have to actually count the number of seats. Sometimes subtraction isn't the best shortcut. Sometimes you actually have to count on your fingers. A3, A4, A5, A6, A7, A8, 6. Okay? Just making sure you don't suddenly... Because I have some kids, they look at that and they go, oh, there's 5 people. Count the people. 6. How many blanks? Any restrictions? Stop. I'm not going to draw the blanks. How many ways can I rearrange 6 different objects with no restrictions? What's the shortcut? Okay. This is the level that I'm comfortable at. which I think is 720. Double check me. Okay. Let's bring some romance. You may have dealt with this. You're going to a hockey game, and in your group of friends, there's a couple, and they have to sit next to each other. So how many arrangements? Okay, you know what? I'll treat them as one funky Scrabble tile. I'm going to go to my grab bag. And I have on one Scrabble tile, what else do I have in the Scrabble tile? Frank, Iris, Jacob, and Kim. Question, Mackenzie? You're good? So if you're good, Mackenzie, how many blanks am I going to draw based on my Scrabble bag? Not 6. What's a short way to mix up 5 blanks? Okay, so in our notes, so when you're studying, let's put the 1, 2, 3, 4, 5, and I'm going to write 5 factorial underneath it. If you get comfy in your homework, that you feel good going to the shortcut without drawing a blank, go ahead. 5, 4, 3, 2. Does it say that George and Hannah have to sit in the order George and Hannah, or does it just say they have to be together? So I can mix up that little special Scrabble tile. How many letters are there on that mini special Scrabble tile? How many ways can I mix that up? Technically 2 factorial, but 2 factorial is 2 times 1 is just 2. Okay. 240. You may have dealt with part C as well. You're walking to the game, and suddenly you hear some shouting behind you. Okay, George and Hannah have just had a nasty fight. They refuse to sit together. How many ways can you do that? There is no easy way to calculate this directly. But we can be clever. Ready? What did I find in part A? What did we find in part A? In English. Total number of seating arrangements. What did I find in part B? In English.
Total amount of seating arrangements. George and Hannah sat together. If
they sit next to each other, how can I use A and B to figure out how many ways they don't sit next to each other? Subtract. Not divide, subtract. That's going to be another trick. We're going to fairly often find it's far too tough to solve a question. It's much easier to find it not happening and subtract. It's going to be equals what? I can do this in my head. 480, right? Now, in real life, the answer would be much smaller because all of you know you never want to sit next to any member of a couple after they've just had a fight. Because whether it's the boy or the girl, what are they going to be talking to you about during the entire hockey game? The argument. So, in real life, the answer is, right? Believe me. And if you haven't experienced that one, awkward. And then they want to be your friend. Would you pass a note? Could you tell them that? No, I'm not going to be the go-it. Okay. So homework, I gave you some from last day. You're going to get 45 minutes, which was my goal to give you most of this class. What else can you try? Now, I have to be careful because some of these get nasty very quickly, very fast. 1 is good. I can do all of 1. 2 is good. I think we can handle 3. 4a is easy. It's going to be 7 factorial. H, that's one restriction. You know what? 4 we can handle. Oh, hang on. There's more. Hang on. Circle 4, but I might cross. Let me. How many 3-letter words beginning with a vowel can be made? This is probably tougher than I'll ask on a test. I'm going to leave it on the homework. If you find it tough, I'll happily talk about it Friday. F is fair game, though. 5 is good. Skip 6. Seven is good. Okay. 8 is good. The number of ways in which one silver vehicle is at the beginning, another in the middle. Okay, I can do that restriction. I'd probably draw a blank. Okay, 9 is good. Ten. 11, skip 12, skip 13. Why am I giving you so much? I learned, this used to be part of, by the way, you're doing what used to be part of the old Principles of Math 12 academic course, this whole unit. I found kids had to practice these to kind of get their strategies because unfortunately it seems really easy in the notes when we're drawing a blank. What you have to get good at is turning a new question into a Scrabble bag or drawing a blank or a word that you've already done before, and that takes practice. I'm going to shut up.